Start.
Dear student, reaction mechanism is a very basic topic from organic chemistry. To decide what is the reactant and how the reactant converted into product, and after converting what type of mechanism are possible, then these are the very important things related with the reaction mechanism. Suppose for example, we have very simple reaction. Suppose we have alkyl halide. Alkyl halide on boiling with aqueous NaOH, then it gives the product alcohol plus NaX. How the alkyl halide convert into alcohol? What is the intermediate of this reaction? And what is the mechanism part of this reaction? That all concept we are discussing in the reaction mechanism. To better understand the reaction mechanism, you must know some important basic concept related in the organic chemistry or basic effect. In that basic effect, the first effect which is very important for the organic chemistry, that effect is called as the inductive effect. The second effect, that one is also very important in organic chemistry. That second effect is called as the resonance effect. Then later on, third effect is also very important in the organic chemistry. That third effect is called as the hyperconjugation. Like this, so many effects are there. But these are the three supreme and prime effects that decide what is the stability of that intermediate, what is the acidic strength of that particular compound, what is the basic strength of that particular compound, and how the breaking of that chemical bond takes place and how the making of that chemical bond takes place. So, for the detailed discussion of reaction mechanism, first we will discuss systematically these three effects. Then later on, what is the application of these three effects in organic chemistry. Suppose for example, now let's consider the first and very important effect in organic chemistry. That first effect is called as the inductive effect. Dear student, once you know the inductive effect, inductive also one of the important effect in organic chemistry. In inductive effect, or what is the perfect definition of inductive effect? Suppose for example, we have such type of compound CH3, CH2, CH2 bond Cl. In organic chemistry, we say this is 1-chlorobutane. I know very well, in 1-chlorobutane, the chlorine attached to carbon atom, it means chlorine is the more electronegative than carbon. So due to high electronegativity, these are the sigma electron which slightly transport towards the chlorine. It means that the bond present between carbon and chlorine, this bond is the polar bond. Why this bond is polar? Due to difference in the electronegativity of carbon and chlorine. So what is the polarity of this bond? In this case, chlorine become partially negative and carbon become the partially positive. This is the polarity. It means due to difference in electronegativity, the partial positive and negative charges present on this particular atom. Now what happened? Now this carbon becomes the positive. Therefore the electron withdrawing capacity of this carbon is more than this. Therefore this carbon withdraw electron from this carbon atom, and this carbon also becomes slightly positive. This carbon withdraw electron from third carbon, this also becomes the slightly positive, and so on. It means what is the inductive effect? That is permanent polarization of covalent bond. Inductive effect is the effect of covalent bond. Keep in your mind, this is very important. The permanent polarization of covalent bond due to difference in the electronegativity of bonded atom is called as inductive effect. But actual definition we are considering in organic chemistry. The inductive effect is nothing but, no doubt, carbon-chlorine bond is polar bond due to difference in electronegativity. But carbon-carbon bond is non-polar now, because this bond present between the same atom. But due to this polar bond, adjacent non-polar bond also become the polar. And the adjacent non-polar bond become the polar due to neighboring polar bond. Then such effect is called as the inductive effect. In inductive effect, it has some important things which are the important character. The first important character, inductive effect transfer via sigma bond. Listen, this effect is not related with the pi bond. Those molecules which have a sigma bond and such structure, neighboring polar bond and adjacent non-polar bond, the non-polar become the polar, then this is the inductive. Another important thing, inductive effect transfer via carbon chain. It means that the first carbon is positive due to electronegativity, but second carbon is positive due to the electronegativity of this carbon atom. It means this transfer via carbon chain, and after transferring via carbon chain, this become negligible after carbon 4. It means carbon chain, and this is up to only 4 carbon. The third and very important things related with this, inductive effect are of two types. Which is that two type? Either inductive effect are negative inductive effect or inductive effect are positive inductive effect. Now, how to decide whether the particular substituent create the negative inductive or positive inductive? I will give you very simple idea to you. Suppose for example we have this type of compound CH3 bond CH2 bond CH2 bond CH2 bond Cl. Now in this case chlorine is the more electronegative than carbon. So due to higher electronegativity of chlorine, this chlorine accept or withdraw sigma electron or electron density of this whole molecule toward itself. Nah? It means that chlorine accept electron density toward itself. It means chlorine create the negative inductive. It means if electron density of carbon chain transfer toward the particular atom and that atom is must be more electronegative than this carbon atom, then such effect is called as negative inductive. And suppose what is the meaning of positive inductive? Suppose for example we have this type of phenomenon. Suppose CH3 CH2 bond Na. Now what happened here? Sodium is the metal. Metal never become the negative. Metal is always positive. Now what's happened? The moment of electron like this way. The moment of electron is like this way. It means electron of that atom transfer toward the molecule. In this case what's happened? Electron from molecule transfer toward the atom and electron from atom transfer toward the molecule. Then such effect is called as the positive inductive. It means that inductive effect are of two types. Those atom or group of atom accept the electron from the chain, then such effect is called as negative inductive. And if any atom or group of atom donate the electron toward the carbon chain, such effect is called as the positive inductive. Now, which are the group create the negative inductive, and also power of negative inductive is also very important. Suppose for example we have this type of molecule. Suppose OR2 plus. Now if we put OR2 plus in place of fluorine, oxygen carry positive charge. Due to positive charge of oxygen atom act as an electron withdrawing group, and it withdraw electron density from this molecule. Therefore, this create the negative inductive. After that OR2 plus, suppose for example we consider NR3 plus. This is quaternary nitrogen. Now, suppose for example, no doubt the positive means these are the negative inductive group. But when if such type of question are asked and they ask you the question like this, in between these two, which one is a more powerful negative inductive or which show more powerful negative inductive, then OR2 plus is more powerful than NR3. Then how we decide this? You know very well, these are the two positively charged species, and positive charge on more electronegative atom is always less stable. Now you know electronegativity of oxygen is greater than nitrogen, so positive on oxygen is less stable than nitrogen, and if positive is less stable, then it withdraw electron immediately. That's why OR2 plus is more powerful than NR3. Then later on, after the NR3, suppose we are considering NO2. Now what happened in this NO2? In NO2, nitrogen carry positive charge, but that positive stabilized by neighboring oxygen. The power of this NO2 is less than this. So in negative inductive, so many groups are there. For example, after that NO2, we consider here cyanide. Then after the cyanide, we consider here aldehyde. Then after aldehyde, we consider here ketone. After ketone, we consider here carboxylic acid. After carboxylic acid, we consider here ester. So how to choose or how to decide whether the such group create negative inductive? Very simple. Now I will give you one best example to you. Suppose for example, suppose we have one molecule. See toward this. Suppose we have one molecule. Now I am representing in front of you an organic compound. CH3 bond CH2 bond C double bond OH. Now this is the butyric acid. So what is the effect of this COH on this carbon chain? You decide very simply. How? You know very well. Hybridization of this carbon is sp2. Yes or no? Yes, because this sp2 carbon, this carbon attached to only 3 sigma bond and 1 pi bond. Therefore hybridization is sp2. And hybridization of this carbon is sp3. Now what happened here? The electronegativity of sp2 carbon is always greater than electronegativity of sp3. It means that this carbon become the more electronegative than this. So same condition are maintained here. Due to high electronegativity, this carbon withdraw electron from the carbon chain. So listen very carefully. Now how to decide whether this group create the negative inductive or positive inductive? If the attached carbon atom or electronegativity of this carbon is more than the neighboring carbon, then no doubt this is the negative inductive. See, this is sp hybridized carbon, this is sp2 carbon, sp2 carbon, sp2 carbon, sp2 carbon, and so on. It means it is very simple to you how to decide whether the given group create the negative inductive or positive inductive. Now what happened here in positive inductive? Suppose for example we have a O minus, O minus. What indicate this O minus? Now what is difference between plus and minus? Minus means it is electron rich. And electron rich species are always electron donating. Therefore O minus create the negative, positive inductive, sorry. After that O minus, then we simply say that all alkyl group, all alkyl groups. What is the meaning of all alkyl? Suppose for example we have tertiary butyl. Suppose for example we have tertiary butyl. Or suppose for example we have isopropyl. Or suppose for example we have ethyl. Or for example we have methyl, and so on. And these are the alkyl group which create the positive inductive effect. So these are the electron donating. Hybridization of all these carbon is sp3. It means to donate the electron toward the, suppose I will give one example to you. Now suppose I have this type of compound, now this attached to CS3. If I ask you one question, what is the effect of CS3 on this benzene ring? Now the carbon of benzene is sp2 hybridized and carbon of CS3 is sp3 hybridized. It means that electronegativity of this carbon is more than the CS3 carbon. Therefore CS3 donate electron density toward this carbon atom. Therefore what happened? CS3 acts as electron donating group, and those atom or group donate the electron, then such inductive is called as the positive inductive. So listen very carefully. This is the very basic and important effect present in organic chemistry. This is called as inductive. By using inductive effect, we decide the stability of carbocation, stability of carbanion, acidic strength, basic strength, etc. Now, how to apply this inductive effect in organic chemistry? Now we are discussing some example. Listen, see the example of this. Suppose we have some compound, or suppose we have some organic acids. Suppose for example we have a formic acid, you know, HCOOH. Suppose for example we have CS3COOH, acetic acid. Suppose for example we have a CS3CS2COOH. They ask you the such type of basic concept or basic question in organic chemistry in your CSR examination or NET examination or SET examination. Now, if we want to compare what is the acidic strength of these three acids. Suppose for example, now how to decide the acidic strength? First I will give you one idea to you how to decide the acidic strength, and then directly we say which one is stronger or which one is weaker. Now acid means what? According to Arrhenius theory, the substance which has the tendency to donate the proton in aqueous solution. It means proton donation capacity. Those substances which have a greater tendency to donate the proton, then that becomes the stronger acid. Now another alternate definition of acid is also there. The alternate definition is like this. Suppose for example we have this H bond COOH. This is organic acid. In aqueous solution, organic acid, so equilibrium HCOO minus, and this is the H plus. Now if equilibrium shifted to the forward direction, it means more and more H plus ion is produces. It means acidic strength is more. So whether the acidic strength is more or less, it depends upon the stability of this conjugate base, because every acid has its conjugate base. Now what is acidic strength of this formic acid depends on the stability of conjugate base. If this conjugate base, suppose for example this is the conjugate base COO minus, listen very carefully, this is the conjugate base of acid. Now suppose if this conjugate base is more stable, then this conjugate base doesn't accept the proton back and never equilibrium shifted toward the backward. Equilibrium always in the forward direction if it is a weak. Now the strength of this conjugate base depends upon either electron withdrawing group, or strength of this conjugate base depends upon electron donating group. Now electron withdrawing means what? This is called as minus I effect. Electron donating means what? This is called as the plus I effect. See, this is very important things. If electron withdrawing group attached to carboxylate ion or this conjugate base, then what happens? This electron withdrawing group withdraw negative electron density toward itself. It means dispersion of this negative charge toward the electron withdrawing group takes place. It means electron density on oxygen is reduces. And electron donating group, what happens? Electron donating group donate the electron density toward the oxygen atom. It means the electron density of the negative charge increases. If electron density on negative is decreases, it means automatically stability of negative increases. If stability of negative increases, then the acidic strength is more and more. It means, what is the final conclusion? The acidic strength of carboxylic acid, listen very carefully, this is very important. Acidic strength of carboxylic acid is directly proportional to what? Negative inductive, or inversely proportional to what? Positive inductive. Now suppose we have a different negative inductive group, then what happen at that time? Just to see the power of negative. And suppose we have a different positive, then just to see the power of positive. Now see here. Now what happened in the formic acid? Now this carbon attached to hydrogen atom. See, the hydrogen is hydrogen never create any type of inductive. Inductive effect of hydrogen atom is zero. Now this attached to CH3 group and this attached to CH3-CH2 group. Now the inductive effect of hydrogen is zero. Methyl group create the positive inductive. Ethyl group also create the positive inductive. But out of these two positive inductive, the positive inductive of ethyl is more than the methyl, na? So that's why the acidic strength of formic acid is always better than acetic acid, because in acetic acid positive inductive group is there, and acidic strength of acetic acid is always better than the propanoic acid, because in propanoic acid, both have a positive inductive, but inductive power of the ethyl group is always greater than the methyl group. Therefore, this is the best example to decide acidic strength of the particular compound. Now, now we are moving to the second example. Second example we will discuss in the next video. Thank you.